So then next thing we move on to is some common types of heat pumps. So the most common type of heat pumps out there are air-to-air heat pumps, air-to-water heat pumps, ground source heat pumps, and open source heat pumps. So in the next few slides, we're going to be looking at these types of heat pump, a brief description about what they are, and then we're going to look at some slides of a few manufacturers, diagrams for how their heat pumps work, and also a few pictures of heat pumps out in the field, so you know what they actually look like out there. We're not going to be going too deep into how they run because that's for a future webinar. So let's move on to air-to-air heat pumps. So these are actually my favourite, obviously, of course, because I've been working with them for so long. So you've got our air-to-air heat pumps. Now, they're most commonly known as air conditioning units, and they include the following types. There is more, but these are the main types. You've got a split type system. Now, when you've got a split type system, that's defined as one indoor unit that is attached to one outdoor unit. You have a split type multi-system. So if somebody says they're having a multi-system installed, this is when there's more units connected to an outdoor unit, but each unit has its own refrigerant pipework and is capable of working as a split system. A lot of people have these if they haven't got space for many condensers, or they just don't really want to have a look at lots of condensers out there. Then you will have a split type twin, triple, or even a quad type system. And this is when you have more than one unit connected to an outdoor unit, but they're all sharing the same refrigerant pipework and working collectively. One cannot be run without the other. So if you had a twin, triple, or a quad system, they all have to be run. They're all going to be in the same mode, and they're all going to be heating and cooling at the same time. Typically, you put something like that if you had a long office, and you wanted to just use one system in there, you might put 1, 2, 3 all the way down that line. Our next common air-to-air heat pump is the VRF or VRV, which stands for variable refrigerant flow. The heat pump type is typically two-pipe, and that's when you've got multiple indoor units connected to one outdoor unit. Each unit is capable of its own temperature control, but the mode, heating or cooling, is set collectively for all the units. The next one, what you might hear about, what people talk, is the heat recovery type. So the VRF, the VRV heat recovery type, that's same as the above, but each unit is capable of either heating or cooling independently. During the recovery operation, when some units are in heating and some units are in cooling, then you can really maximize out the efficiency of that system. So for instance, if you had a stock system and it had a COP or of 4 or an IOR around about 4, so 1 kilowatt of duty electric input in for 4 kilowatts out. If we make the system really simple, that you had 10 units and 5 units were in heating and 5 units for in cooling, then you're going to double up on that, because what it'll do is it'll actually absorb heat from one part of the building and move it into the other part, and the outdoor unit, which is the condenser, will just be circulating the refrigerant around, and during that stage you can double up the efficiency of up to 8. So you could have 1 kilowatt of energy used and then maybe up to 8 kilowatts of duty inside your building. One of the other common ones, what you might see, is DX condensers, and that's when outdoor units are connected to a coil, normally within an air handling unit. Typically, mostly you'll see them for cooling, but a lot of times now with air handlers with heat recovery on there and thermal wheels, they will have them as heat pumps, and they will heat the air as well as cool the air. Let's have a quick chat about the benefits of an air-to-air heat pump. So an air-to-air heat pump is ultimately more efficient than other heat pump systems. This is due to the fact that it only has to exchange the heat once, outside air, direct to inside air. They have a really quick response time to internal temperature adjustments or a quick change. Also, if there's a change to outside temperature, they can react really quick. And also you get the benefit of cooling in summer. Drawbacks. The interconnecting pipework contains refrigerant, so of course due to that they have to be installed by certified professionals, i.e. F-gas trained technicians and REFCON certified companies. The air source heat pumps, other drawback is that they are subject to ice formation in winter, which means that they do periodically need to defrost. And when that happens, you can have a lack of heating in the building. So it just depends how good that building is, or if there's some ventilation in there that's depending on the heat from the system, you could have 10-15 minutes every so often of no heat in there. So that can be a drawback. There are systems out there that will give continuous heating, but that continuous heating is at a reduced level. Also, as well, as it is an heat pump, the efficiency can drop off, and also the kilowatt output can drop off as the outdoor temperatures drop below -5. So you do have to be conscious that when you're sizing one of these heat pumps, that you do size it and rate it for at least -5. We have a quick look at some pictures of equipment out in the field. So this is a picture of a commercial site, and then what we're looking at is the larger split systems and VRF and VRV external condensers. So you can see the VRF condensers at the back, they're typically a lot bigger than the split systems. And then you've got these double fan condensers at the front. They could be attached to single split systems, or they could be attached to twin or triple type systems. We've got a couple of examples of the smaller commercial domestic split systems, installations and external condensers. They're mostly what you see there, what most people are familiar with looking at when they're walking around buildings. Then we'll have a look at some examples of the air-to-air heat pump indoor units. So when people are talking about the units and they're asking for a particular type, or you're explaining what type you're going to be providing for that client, you've got the under ceiling unit on the left. In the middle, you typically call that a floor mount, and then the unit on the right hand side, that's typically called a ceiling cassette. Some more units that are really popular on air-to-air heat pumps. The one on the left is called a floor cabinet. They're typically just mounted on floor, just sucking air from the bottom and blow it out at the top. I'm actually a big fan of these. They've got a really good throw. And the most common one in the middle is the wall-mounted unit. And then the unit on the right is a ducted fan coil. It's really difficult to get a good picture of fan coil because they're usually hidden away above ceilings and connected to grills. Lots of office blocks tend to have ducted fan coil units because as their offices change, it's more easy to move the grills than it is to move the units. So you do tend to find it in office blocks. You get a lot of ducted units in there.